Hi, and welcome back to another episode of Math Explained. Today we're going to be looking at solving linear equations. There are many different kinds of linear equations, so we're going to start with a very basic, a one-step equation. A one-step equation might look like x plus 5 equals 8. For me to solve and get this x all by itself, what we want to do is the inverse operations. Since I have a plus 5, what I have to do is subtract 5 because I need this to get to 0 and disappear. 5 minus 5 is 0, so those will cancel. But what you do to one side, you must do to the other. And so now we're left with our answer of x equals 8 minus 5 is 3. Let's try one that says negative 3 plus x equals 10. Once again, I want to do the inverse operation. So if I want to get this x all by itself, I need to make sure that this minus 3 turns into 0. And the way to get to 0 is to add 3, once again using inverse operation. If I add 3 to one side, I have to add it to the other. Now these will cancel. And our answer is 10 plus 3, which is 13. So that is a one-step equation with having to inverse an addition or a subtraction. What about if we had x being divided by 6 and that equaled 2? Well, since x is being divided by 6, the inverse or the opposite of that is to now multiply both sides by 6. Because 6 divided by 6 is 1. That cancels out, leaving just our x. 2 times 6 is 12. If I had 4x equaling 3, when you don't see an operation between x and there's a leading coefficient in front of it, so there's no plus or minus or division between here, there's no symbol, that's telling you that these are multiplying together. So 4x is basically 4 times x, and the inverse of multiplying would be to divide both sides by 4. Whatever got attached to x is what we need to divide on for that to cancel. And so my answer is simply x equals 3 over 4. These are one-step equations. Now let's take a look at a two-step equation. That would look like something if I had 2x minus 16 equals 2. Once again, I want to get x by itself. I am going to include if there's something attached to it to save that for the last step. So my first step would be to doing the opposite of subtracting 16, and that is adding 16. And we'll do that to both sides. That will now cancel because that becomes 0. And we are left with 2x equals 2 plus 16 is 18. Now I've done the first step, I'm down to a one-step equation, the second part. And what is the opposite of multiplying 2x? It is to divide both sides by 2. That way that cancels, and x would equal 18 divided by 2 is 9. So our solution would be 9. Let's try another one. If I had 25 equals j being divided by a 4, and then I add 23. Once again, if I'm trying to get the variable all by itself, I'm going to include anything that is attached to it. So I'm going to be dealing with that addition or subtraction first. It makes life a little bit easier. And so we want to get this to 0, so we need to subtract 23 from both sides. And now I am left with 25 minus 23 is 2, and j being divided by 4. Here is another one-step equation where we must do the inverse operation. And the inverse of dividing by 4 is to multiply both sides by 4. So that those 4's cancel, and j now equals 8. Great. Let's try one more on a two-step equation. How about over here? If I have x being divided by 2, and then I subtract 2.24. Throw a decimal in here, and that equals negative 0.24. What is the first step that I need to do to solve for x? If you thought add 2.24, you're correct because we want to deal with that addition or subtraction piece first. So let's add 2.24 to both sides. That will now cancel. We are left with x divided by 2. On the right-hand side, if we were at minus 0.24 and we added 2.24, I am now at just a positive 2. Now I have a one-step equation where I must do the inverse of a division, and that would be to multiply. These will cancel, and our final answer is 2 times 2, which is 4. Wonderful. These are two-step equations. I'm going to show you a different two-step equation. And it's basically the same thing, but it just looks different. If I had x minus 2, and that whole thing is being divided by 2 to equal 3, well, now can I do that first step of adding 2? I cannot, because there's division happening to both terms. So now what I would want to do is I need to be multiplying this entire thing by 2 first. And we'll multiply this side by 2. That will cancel the 2's out from here. And now we have x minus 2 equals 6. So our final step here is no longer the multiplication or division, it's actually the inverse of subtraction, which is to add. Those will cancel, and 6 plus 2, our answer is 8. So notice the difference from the previous questions. In these ones, the division was only to the variable. So I dealt with any addition or subtraction first. If it was a multiplication only to the variable, I dealt with the addition or subtraction first. In this one, the division was to both, so I have to deal with that first. Let's try one more like that. Let's say we have x minus 10 being divided by negative 2 all equals negative 3. Once again, this division is happening to everything, both terms here. So I must multiply that entire group by negative 2 to cancel that out. Now I've got x minus 10, negative 3 times 2. When you multiply a negative times a positive, it is a negative number. And now the last step would be to inverse a subtraction of 10. So I must add 10 to both sides. Minus 6 plus 10. Do you remember your integer rules? When you are adding one positive number to one negative number, the larger number, in this case 10 is bigger than 6, tells you the sign of your answer. So this answer must be positive. And then I just see how many numbers are between 6 and 10. There are 4. That's one of our integer rules. And now let's try a more complex equation. Let's try 4 times x plus 19 minus 2 equals 14. This is no longer just a two-step equation, because what we have to do here is our distributive property. Our distributive property is when we multiply any number that sits outside the bracket into all the terms that are inside this bracket. So 4 times x just becomes 4x. What is 4 times 19? Well, that's 76. Since there is an addition here, I'm going to go plus 76. The 4 does not multiply to the minus 2 because it is not in the bracket, so I'm just going to rewrite minus 2. Now we can look at collecting our like terms. We've got two constants here. Do you remember what a constant is? It's a number without a variable. So we can combine those like terms together. 76 minus 2 is 74. Now what we're looking at is a two-step equation. Do you remember the first step in trying to get x all by itself? In this case, since it's we have 4 attached to x and there's nothing happening to everything, I will be subtracting 74 from both sides. That way this becomes 0, leaving us with the 4x. Now we can figure out what is 14 minus 74. Once again, remember that integer rule. Which number, since we have a positive 14 and a negative 74, we look at which number is bigger. 74 is a larger number. That tells me the answer must be negative. And now I look at a subtraction. How many digits are between 74 and 14? And that is 60. Our last step is to divide by whatever is attached to the variable, because this right now is 4 times x. And the opposite of multiplying would be to divide. So our final answer is going to be negative, because a negative divided by a positive is a negative, and 4 goes into 60 20 times. So there is our final solution. So go over, you have one-step equations, which only involves doing one thing, either adding, subtracting, multiplying, or dividing to get your answer. 2 steps where you will need to do both, and the 2-step depends on if the x is being multiplied or divided to all terms. In these cases, it's not. In this example, x was being divided, but so was the other term. So we dealt with the multiplication first. Or if it had been on the outside, like we did in the last one, now we need to distribute and then solve for x. If you have any questions or comments, or would like to see additional questions, please leave your comments below.